Hi, and welcome to the AAS Journal Data Series. This is our next episode of the Journal Series. I am Mubdi Rahman, and I'm joined here with Frank Timmins. Thank you so much for joining me on what's going to be, hopefully be a fun informational session. How are you doing today, Frank?
It is April 4th, 2022 as we shoot this. I'm doing really well. Spring is in the air. I have grapes. I grow
Wonderful.
grapevines off my side of my wall. And so all of them have their little buds out and the little bees are starting to do their thing. So in about 2-3 months, I'm going to have some grapes,
That'll
which
be fantastic.
I may experiment with. I've never done it before, but maybe I'll turn it into a glass of wine, and then I'll probably write a software paper.
Well, you know what? That is a fantastic segue. I am glad that it is a little warmer there where, I'm based up in Toronto. It's a little cooler, not quite grape growing weather yet, but not far away, hopefully.
Yeah, and I've had good Canadian wines. It's good.
Yeah, I know that we're famous actually for ice wines. So especially in just south of us, the Niagara region, they're very famous for the ice wines. So we'll have to send you some and do a comparison of your wine versus the ice wines.
Definitely be right.
Arizona Vintage 2022, right?
Absolutely, very cool.
But as you alluded to, we're going to be talking about software papers today, which is a new and fantastic and growing, type of paper that we have, that we're excited about at the AAS Journals to have and to accept and to start having people submit them and create them and discover new software. Have you played around with software papers much, Frank? I know you've seen a bunch through your role as an editor.
Yeah, I've written 1 or 2 software papers before in my life. Submitted to the APJ supplement, tends to be my preferred vehicle for them. But I enjoy software papers. I enjoy being a scientific editor on software papers that come through. Yeah, I highly encourage people to submit their software papers, whether that software is a little bit more focused on the software itself as the entity in and of itself, or whether it's a software instrument that's applied to a given phenomena.
And it's so critical, especially in this day and age where software makes the science, and we'll talk a little bit about that, where just we don't sit with ledgers of numbers anymore, tabulating them and like marking down locations of spectra. The software is what does it, and so getting a sense of how that software is doing it really does affect how the science happens.
Okay, I like software papers, so yeah.
Well, let's get started, and let me start by sharing a couple of slides. So let's start off by, today's topic is, what is a software paper? It's a very open question as to what creates a software paper. And one of the things that astronomy is a little later to the field of, but we're really speeding up and meeting our collaborators in, biomedical physics or biology or medical science is methods papers, right? So this is something that is a little less common in astronomy. You see it in big collaborations often, that they'll have methods papers associated with, with very, very large results. So you can imagine things like the cosmology experiments have have a series of method papers that go with them, but it's not super common. Whereas you look at something like biology, there are journals dedicated to methods papers that are there just to tell you about new ways of doing things. And this is something that's becoming a lot more common in astronomy, especially with the advent of these incredible software packages that you as the community are developing and allowing much of the community to learn all about and build on and do their science with. These are our form of methods papers, and so that's kind of a good way of thinking of software papers. These are astronomy's methods papers.
Okay, cool. I like that analogy. Very good.
But we have a very specific, well, just to give you a sense, software makes science happen, and software is science, right? There's two aspects of that. One is, like I was mentioning, we don't have large lectures of numbers that we're recording where we're looking by our eyesight and measuring whether or not Vega looks like it's down by half magnitude based on my our eyes. Which, if you look at some of the archives of especially the Astronomical Journal, you can see papers from the 1800s that are exactly that.
Exactly.
But we've we've evolved as a field and gotten a little more sophisticated with how we do that. But what that means is that the way that our results are derived and the way that we collect data is really dependent on the different processes and the different algorithms and the different reductions techniques and steps that we do in them, and that's software, right? In a generic term, all of that's software. And in many cases, you can put that in the methods section or the procedure section of your own paper. But in many cases, it's too much, right? Sometimes you want that result to be, standalone, but there's very technical details that have gone into what you're doing in this that deserve its own paper and its own consideration on its own. And then secondly, the thing that I'd like to bring up is that software is often science, right? The way that we do the science, the way that we create these new software tools and ways of dealing with data and ways of capturing data can radically change the way that we do science and what the science that is accessible to us. So that software, you can think of simulation software, right? Like, back in the mid to late 90s, one of the things that was super common because of the nature of computers and the limitations of computers was most magnetohydrodynamic simulations, or hydrodynamic simulations for that matter, were all two-dimensional. Right, that was a very, very common thing to do to try to reduce the complexity of the scale. And there were some really interesting results that came out of that. But then, fast forward to the 2000s and the 2010s, our ability to compute has dramatically increased. Cluster sizes, processors, all of that. So we have the ability to do three-dimensional simulations. And guess what? Fluids work differently in 3 dimensions than they do in 2 dimensions. And so a lot of, dramatically different science happens because of that. And a lot of this needs to, was captured in various papers along the way, but the methods really matter and how you do that solving.
Absolutely. Very cool.
And this is, particularly, I know, people who are particularly care about plasma physics have run into this problem over and over again. The way that you write that algorithm, the way that you write, that magnetic reconnection script, or the way, all of that really affects what the result that you get at. So being able to capture that, being able to make it reproducible is critical.
Exactly. Right. So part of this is introducing a tool, or the tool that you're using, to the community, describing in detail, what you're doing in there.
Well, so the AAS has a definition of a software paper.
Okay.
So this comes from our software policy. And a software paper is a peer-reviewed paper appearing at one of the AAS journals. So APJ, the Astrophysical Journal, the Astronomical Journal, APJ Letters, the APJ Supplement Series, or the Planetary Science Journal, that describes code or software that has been developed in aid of scientific research. And so there's just a couple key points there. One is it is an aid of scientific research. That doesn't necessarily mean a research result has already come out from it. It just means that it is with the intention of being able to help research or produce research results. So what's in a software paper? Within the confines of a software paper, it really, what the goal of them is describing the principles of the software and how they're implemented. So, very simply, the idea there is you want to be able to tell people in this paper, what is this software supposed to do? What scientific problem is it supposed to, solve or help, modify or help us, address? What decisions you made in creating that software, and often, how do you actually get access to it if you are in the position of distributing it? right? And so you can imagine so many different use cases of where a software paper is necessary. Like for instance, let's say that you are a part of a big data experiment or a big, observatory experiment. Where you're collecting large amounts of data and putting it through a pipeline to reduce it from its raw data and raw, voltage counts on some sort of detector to an astrophysical measurement,
Mm-hmm.
right? You can imagine that technique, you're not going to describe that in 2 paragraphs in the science paper, right? In
Oh,
fact, you would be doing yourself a disservice if you did that. And one of our editors will be not very happy with you at some point because there'll be just so much that's compact in there. But every single one of those stages has a different scientific decision that you made, either
mhm.
scientific or even technical decision, right? And so, what a software paper allows you to do is it allows you to take these, describe each of these technical and scientific decisions
Mhm.
and say this is how you'd be able to reproduce this code. If you wanted to remake this code, if you wanted to test this code against a different method, these are the stages you'd need to change. These are the algorithms that I used
Uh-huh.
to do this and to process this, and this is what it looks like.
Uh-huh.
So that's really the core of software paper, is that it's telling you how your software is doing the science you told it to do.
Right. I would like to distinguish this as different than a user manual.
That is correct. In fact, that is a perfect segue to what isn't a software
Oh,
paper.
okay.
So again, no, you had it right there. And so there's a couple of distinctions between what a software paper is and what often we think of when we talk about software documentation. So
Okay.
one of the key things is, as you point out, Frank, it's not the documentation of the software.
Yep.
It is not a description of how to run it. It is not a description of every single possible configuration you can put in it.
Yeah.
Yeah, entirely. It's not a description of where files go, where once you've saved things out. All of that stuff should be reserved for documentation, and that stuff, arguably it should be changing. It will, as your software evolves, you will change that over time and time again. You add new features, and that will change certain configuration parameters and the way you compile it. You change the version of Python, you change the operating system. All these things are things that you
Yes.
will change regularly, and you don't want that to be a part of the paper. The paper here is to really describe what the software is intended to do and how it makes its scientific decisions on how to do that.
Correct. And usually in a scientific software paper, you're doing verification analysis, like you're comparing it to some other code, you're comparing it to an analytical result.
That's
So
right. Yeah.
here's all the choices we made, and now here's sort of like some with any given field, right? Here's sort of the verification problems, right? Like it can do a shock problem, it can do
That's right.
extraction of Lyman alpha or whatever it may be.
Exactly. That's right. In fact, that actually brings me to my next point of what a software paper isn't. A perfect segue there, Frank. But what it isn't it's not a computer science paper, right?
Correct.
It is an astronomy paper inherently, right? It is meant for astronomers. The target audience is astronomers. You want to be doing comparisons that astronomers would care about, not necessarily and there's certainly a lot of good astronomy computer science papers that deserve publishing in their own right, but that's not what this is meant to be. This is meant to be a description for astronomers that want to, understand a result that came from the code, or you potentially use the code for their own result, to understand the science that goes into that code. One of the other things that a software paper is not is it does not require you to maintain your software for eternity, right? That's often one of the big hesitations that people have
Okay.
about publishing a software paper. It's like, well, I wrote this code and I'd love for people to use it, but I don't want to get 50,000 emails of people who couldn't configure it, or questions about that, or requests to modify it. You are certainly welcome to do that, and we encourage people who want to build software communities. But just because you write a software paper on that on that particular piece of code doesn't mean it's you're guaranteed to support it for everyone in the astronomy community.
Right. There are various there's various levels of support for different projects, and that often depends on size, it depends on funding, it depends on all of that. But I think for our point here is that that is not a commitment on your part.
That's right.
If you write a software paper, so go ahead and write the software paper describing what it is, even if you don't anticipate, supporting it for the next 20 years.
Exactly, exactly. And there's some great, great community-based software that has been supported for 20 years, right? You
Yeah,
you can think of things like Cloudy that,
there's been a
there's been a
Cloudy's
number
good
of yeah, there's been a number of great astronomers that have actually supported for their own purposes, and it's Cloudy for that. But there's also been software that has been one-off written and has been super useful to the field, but not has not been supported by the original authors of it, right? And this is all of value, right? There's nothing that shouldn't stop you from writing a software paper if you don't intend in 30 years or 40 years to be the one to like fix bugs in that software.
Right.
One of the other things, and this often I know gets to a contentious part of the way we talk about software in astronomy, but we're an open source loving community. The the American Astronomical Society loves open source, but writing a software paper does not mean you have to make your code open source,
Oh, that's true.
right? There's a lot of code, for instance, that you wouldn't be able to make open source. Let's say you work in a government laboratory,
Right.
and you work on MHD simulations, or you work potentially for a company, and you want to do astronomy with the software, and you want them to use it, but you don't have the rights to actually make that fully open source. That's okay. You can still write a software paper on it. Obviously, we love open source. We would love, there's a lot of benefits to having open source software because it enables reproducibility. It enables other people to take a look at what you're doing in your code, and the science decisions that are made and potentially building the next generation of that code. But we understand that there's a diversity of reasons that you may or may not be able to do that.
Absolutely. And it's perfectly okay. And you should still submit your software paper.
That's right. And the last one I want to bring up here, what isn't a software paper? It is not a guarantee that your software is perfect.
Yeah.
That is exactly, because first off, there is no such thing as perfect software, right? That simply does not exist. But secondly, this is another big hesitation that people have when writing software papers. It's like, oh, I want to get it to X stage or these new things, or deals with all of these issues, or and there's that next next, and there's always going to be a next thing that you want to implement. But let me tell you, if people are already using that code for research, it is ready to be published as a software paper, right? If you have published anything else or submitting anything else or have a research result based on that code, you can write a software paper about it. And we know that it'll change. And we'll come back to how we can help you deal with the fact that it's going to change in a little bit.
Okay, let's do that.
So if for a reader, what is the benefit of software papers? So obviously there is the natural ones of, you've seen a result and you want to understand how it's been produced, or you want to, do a similar analysis, maybe in the same field, maybe in a different field, and you want to understand how to create the algorithms, or potentially how to use that software package to do that. But it's also just a great way of finding software, right? Oftentimes, one of the natural things we'll do, and I'm just as guilty of this, and I'm sure, Frank, you've run into this problem where it's like, oh, I know how to solve that problem. Let me just write something quickly to do it. And lo and behold, it never ends up being quick to write that. It ends up being something that's like, oh, I thought I'd get this done in like
lines.
Exactly. That's right. Exactly. And it's, and a couple weeks later and you have something that's half working now. But, oftentimes there is good software that is out there that people have tested and worked on other projects or other programs that is fantastic for your exact use case. And they would love for you to use it.
And it also helps stop reinventing the wheel, right? Not everybody needs to write a route finding algorithm, or
exactly, that's right.
Whatever it may be. Don't need
or in current cases, not everyone needs to have their own machine learning algorithm for X or Y grouping, or
right.
In fact, there's a lot of benefit to building off of somebody else's. In fact, it both helps you because you get to your research faster, but it also potentially helps them because they then learn these new techniques, and that's the benefit of having a community that looks at this. So, one of the great things about publishing software papers is it's a great way for people to find the software and for you to use the software, and especially cross-field. one of the things that I've definitely noticed is that there's often software, especially in older papers, that is described in a paper, right? There's going to be some result, but unless you're in galaxy evolution or specifically galaxy morphology, you wouldn't know about that piece of software, right? It's only ever described in that one thing, whereas it could have potential like value if you're looking at proplyds and with ALMA, for instance, or and so this removes a lot of the software from inherently being associated with one particular subfield of astronomy and
Right.
allows it to be used across. I remember initially a lot of people in the early days of looking for extrasolar planets using spectroscopic methods. A lot of people were actually reusing old binary star spectroscopic methods, but you wouldn't actually necessarily know that
Yeah.
unless you hunted in the binary star literature for this particular thing or that particular thing, whereas software papers allow us to break that out of that particular subfield. And so that's one of the reasons I get super excited about software paper. It really allows us to use the intelligence of everyone's brains to help solve your problem, as opposed to just relying on yourself.
Right. It's not about not reinventing the wheel. It's about contributing to a community. It's about overall making things better for everyone as you go along. It's open science. It's transparent. Yeah. But how do I find that new software? Here we go.
Well, we have so the AAS alongside its partners at the NASA Astrophysical Data System or Service and Zenodo have been working on this project called the Sclepious Project for a few years now. It was actually a Sloan-funded grant to better help understand how we can cite software. This is a big problem, not just in astronomy, but astronomy is a nice, huge, a nice sort of test case for much of academia and much of scientific research for how to try to understand how we cite software, how we cite, A, for the purpose of discoverability, but B, also for the purpose of reusability and reproducibility of science, right? If you entirely. That's a big one, is making sure that people who've done the work to build that software get the credit for it. But the Sclepious project has built a lot of infrastructure behind the scenes, and you'll see it on, on ADS, on this portal that's the Sclepious portal, where you can actually go and you can look at the software. You can see something as a software entry, and you can see all of the papers that cite it. So you can make sure that you can give credit to the people who built the software that you made, but also if you put new software out there, you can get the credit for having written something that helps so many aspects of astronomy. So I strongly encourage everyone to take a look and play around with the Sclepious project. Search for a kind of software or a kind of science that you do and see what is the software that helps create that.
Very cool. Nice search tool.
So this will be a natural question, right? Software evolves, right? Software naturally actually has a very, very quick time scale for evolution, be it like, for some pieces of software, it'll be on a day-to-day basis where you add and improve and you learn more about what your data set's doing or how the software progresses. So how do you deal with that?
And as you mentioned, the underlying systems are constantly evolving. There's new operating systems, there's new compilers. And if you don't keep your code up, it very quickly gets what's referred to as bit rot.
That's right, exactly.
Pilot, you won't be able to run it, etc. And in fact, anybody who's ever written a software paper knows by the time the paper comes out,
it's a completely different version, right?
Like it's relative to what the actual code base is.
That's right, entirely.
So now,
so a software paper is meant to be more timeless, right? That's supposed to be talking about the scientific procedures that you put in there, but those will change as well, right? It's not just going to be about, the documentation should have your updated, information about compilation and all those things of those settings, but the software paper, you'll learn how to do things better in your software over time. But this is one of the fantastic things that the AAS Journals has enabled, is something called living papers. So a software paper can be a living paper. And what do we mean by that? A living paper is one where you can actually add on to the paper after it's been published. You can you can't remove authors, but you can add new authors if there are new authors that have helped develop the software, encouraging, more people in the community to get involved in this. But it also, you can add on sections that will be separately peer reviewed
Yes.
that describe the new software or the new updates to the software. And then thirdly, this second version of the paper will have its own specific citation. So if you're using an old version of the
Yes.
software, you can actually cite that old version of the software paper. But if you're using the new one, you can cite that new one. But collectively, all of them will get all of the citations of everything that has been done with that software. And so
Cool.
it's an exciting ability to build on something,
Hmm.
whereas you don't have to go through the process of writing a separate paper if there's not a need for a separate paper for that, evolution of that piece of software.
Hmm. Very good. I like that.
Yeah, so it's a really cool feature that's been enabled, and we're hoping to see people start to use it as their tools that they build grow, and as the communities that build around them grow.
Hmm. Hmm.
So, in a nutshell, this is what we're talking about when we talk about software papers. But if you stay tuned for the next episode of the Journal Data Series of the AAS here on the YouTube channel, we're going to be actually talking about how to write a great software paper, and maybe talking a little bit about certain examples and certain cases of how you'd write a software paper in different cases. So definitely stay tuned for the next episode.
I am waiting with bated breath. Very cool.
Well, thank you so much, Frank, for letting me talk a little bit about software papers on the
Absolutely.
channel.
It's a topic very close to my heart. And so fantastic. And thank you.
Thank you. And definitely go forth and code some software and then write it up and send it to us.
I shall. See you soon.
Take care.
Bye bye.